Hello guys, welcome to another video. Today we are going to solve a question that says that you have to find the duplicate element in an array of n+1 integers. Meaning there are integers from 1 to n and the size of array is n+1. So there is a duplicate element in that array and you have to find that by using a brute force approach or optimal approach. First let's see the question, what the question is saying. So basically you are given an array and in this array you are given some elements like 1 2 3 4 3. So in this array you have to find the duplicate element. As you can see, duplicate element here is 3. So here the number of integers are n, 1 to n, and the number of means the size of array is n+1, that is 5. So the question says that in this array that you have to find the duplicate and the number of integers is from 1 to n only. So let's look at the brute force approach. So in the brute force approach you can just simply sort the array because the array is not sorted. Just remember that. So when you sort this array, just the array will become like this: 1 2 3 3 4. After sorting it, go from this direction and check if the I element is equal to I+1. If that is the condition, then you have find the duplicate element and just return this element. That is the case, but this brute force approach will take big of n log n. As you know, sorting takes n log n time and the space complexity is big of 1 only because we are not using anything. If the sorting algorithm is taking another thing, then this can become n log n or n. So this is the brute force approach. Let's look at a slightly better approach. We can use a set here. As you know, set only stores one element only one time. So you can store one by one an element in the set basically. Let's get here. First we come here, we check if 1 is in the set. No, it is not. So we place 1 here. We go to this, we check 2 is in the set. No, 2 is not there. We place it. We check 3 is in the set. No, 3 is not there. We place it. We check 4 is not in the set. We place it. After we come to 3, we check 3 is inside set. Yes, 3 is inside set. So we will just return this as the value. So this set approach basically does everything in n time, but there is a space complexity of big of n, and that is not optimal. So what is the optimal approach here? Let's look at the optimal approach. So the optimal approach is basically an technique that is Floyd's tortoise and hare technique. Basically this is a cycle detection technique. This approach is also used in the linked list, where linked list is actually pointing, the end is pointing to an element and that is repeating. So this approach is also used for cycle detections, and here we can see these are pointing to some element here. 1 is pointing to here. So if we go to this, the index 1 is here, then 2 will point to here, 3 will point to here, and 4 point to here, and then this again point to here, and then cycle repeats. So this is a cycle detection technique which is basically used in linked list, but we can use here because we only have integers up till n in the array. So we can use this cycle detection technique to detect what is the number which is repeating. So what this technique says, take a tortoise, take a hare, or you can call it fast pointer, slow pointer, or just fast or slow. What you need to do here is you need to place fast and slow here, and whatever the index that you are getting, you need to go to that index, and this fast pointer will take 2 steps where the slow pointer will only take 1 step. Basically the fast pointer will go like this. Fast is equal to, let's take array as fast. So it is taking two steps, first and second step, and the slow pointer will take only one step. So this is going twice that speed, this is only taking one step. And you have to check if slow is equal to fast. If this is the condition, what you have to do here is you have to stop this process, take the fast pointer to the starting of the array, and now this fast pointer will also take only one step at a time, meaning we will not do anything. We will take another loop where fast is also going at a similar pace, array of fast, and slow is also going at a similar pace, array of slow. And wherever this two pointer meets, that is your duplicate element. So basically what happens here is, let me just give you an example. So for example, one is here, so one is pointing to 2 and this is pointing to 3 is actually pointing to 4, and here as you can see 4 is actually pointing to 3 and 3 is again pointing forward. There is a cycle as you can see. So here we have fast and slow. In the first round, first step, fast will come here and slow will come here. Now again it will take two steps, 1 2, fast will come here and slow will come here. Now as both have meet, we will take fast here and start again. Fast will take one step and come here, and slow will take one step and come here. Then fast will take one step and come here, and slow will take one step and come here. Whenever they meet, this is the element that you need to return because this is the duplicate element. This is the basic approach that you are going to follow. So let's look at the code. So this is the question. Now we need to code this question. So we need two pointers, that is fast, that will be starting from nums of 0. Also we need another pointer that is slow, that will also start from nums of 0. Now here we cannot use while loop because if we check for the condition fast is equal to slow, yes, fast is equal to slow because the first condition is true because those are at the same position num 0. So here we will use do while loop where we first go into the condition, do something, and after that we check the condition. So here we will be placing fast two pointers ahead, so it will go two pointers ahead and slow will go only one pointer ahead. It will be nums of slow. And now we will check the condition. The condition is fast should not equal to slow. If they are, then we are going out of the loop. Now we have checked the condition fast is not equal to slow. It will continue. When the fast is equal to slow, it will come out. Now what we need to do here is we need to assign fast to the first value, that is nums of 0, and now there will be another loop, and this loop is while fast is not equal to slow. Again the same condition but in the while loop. Now what we need to do here is we need to move fast one pointer ahead and slow also one pointer ahead. Whenever these two pointers meets, it will come out of the loop and we are gonna just return slow, meaning nums of slow. This is the value that you needed to return. Let's check. Oh sorry, you actually need to return slow, low, not, because slow is actually containing that value, otherwise it will just print the second value. Now let's submit this question. As you can see, the question has passed. So this is the solution, the most optimal solution, which will not take any space basically, and it will just do your solution in big of n time. So guys, let's meet in the next video. Thank you.